Hello, today I'm gonna solve this circuit with a mesh and super mesh method. A mesh, it's a closed circuit. Here we can see that we have four different meshes that we're gonna name X1, X2, X3, and X4. Then we need to identify our super mesh. Our super mesh are gonna be identified by our current source. This current source could be between two meshes or more. In this example, we have the current source over here, over X2 and X3. So here is our super mesh. Then we need to define our direction analysis. I'm gonna select our clock twice. For now our current, we will need our Ohm's law that tells us that voltage is equal to resistance and a current, and then we will need VLK that tells us that the sum of all voltages is equal to 0. So we need to identify our four equations, one per mesh. First, we have minus 5 volts plus 13 multiplied by x1, and if it appears in another mesh, we rest that mesh. In this example, we don't have any mesh, so we close it. Plus 45, that is x1 minus x2, and we close this equation. Then the second is x4, that is 3 volts 54 x4 minus x2, close. Then our super mesh, it's our super mesh I, that's 1 over 4 A, it's equal to, we need to understand the direction of this to know where it's a positive and the negative. In this case, the positive is this one, it's on your side, so it's x3 minus x2, because they're opposites. And our last, to know our last, we need to identify all the circuit it's outside our super mesh. It's this. So it's 45 x2 minus x1 plus 54 x2 minus x4 plus 25 x3. It's equal to 0. Now I'm gonna make a pause to calculate with my calculator the value of x.
So now we have the value of all our x. It's minus 0.02, minus 0.3, 0.1, minus 0.2. All of these are amperes, and we finish our meshes. So now we need to identify Vx, that we use the Ohm law. So we already have the resistance, plus x1 minus x2. This because x1 entered into a positive one and x2 entered into a negative one. So we only change it, our values over here in our calculator, and we obtain a value of 7.65 voltage. Now we need the power of this. The power is equal to voltage multiplied by current. We already have our current, we need the voltage. The voltage we have, it's with Ohm law, because when you have two parallel components, they have the same voltage. So it's 25 multiplied by x3. That gave us a voltage of 2.6, and this enter into a negative. So to have the power, it's minus 2.6 voltage multiplied by 0.25 amperes. It's equal to minus 0.65 watts of power.